Hi, welcome to these developer skills sprints. We're going to focus on enterprise mobility services, specifically on data access via FIDAC. JT already did a session last Thursday on the enterprise mobility services, so we don't really want to repeat the content of that session, but really focus on the database access side. And my name is Marco Cantu, and I'm actually here in Scotts Valley doing this presentation live because we did it this morning and bumped into a bug, so let's try to redo it. What is a skill sprint is, as you probably know, a very short focus session covering a specific technology, and in this case EMS and with FIDAC, and it's focused on demos. And actually this specific case we'll see more demos and just 2 slides and we're done, and live Q&A at the end, so we'll try to get enough time after the session. So again, the focus is specifically on database access using EMS and FIDAC. And so that's only one of the core features of enterprise mobility services we're focusing on. Again, if I start repeating everything, that will use the entire time for an introduction, which is not the goal here. In terms of the features, what we're going to focus on is basically this bit, which is the FIDAC conduit to other tools, but we're also going to do a little bit of client-side development because we want to have the data available on clients. So this is the slide part, and now we're ready to get into demos. I'm going to show you 2 demos. The first one will be kind of handmade, step-by-step, focused on the FIDAC JSON streaming capability as a way to expose resources from a server, expose a database table from the server, and then consume it in a client using a backend endpoint connection. The next demo will step up and use another very powerful component, which is the FD Schema Adapter, but that will also only see the end result. Okay, so let's get started. So let's build a new EMS application from the ground up. And I want an application that has a resource because I want to expose my database data. So I'm just going next. We need to give this a name. Then this resource name, which you can easily change later in code, is basically the URL portion that we're going to use. So let me just call this data. And I want to have a data module because I'm going to drop the database components there, makes things easier. And then I'm only going to implement one single endpoint, which is the get operation. The get is meant for getting the entire resource, while the get item is for one specific element. So for example, in a database scenario, you could have a get that just selects a few fields and returns the entire query result with a few fields, and then get item, you select one individual record, but you return everything for that record, including blobs or larger data items. Again, this time we're just going to go to get and return the entire resource. So this is our server. This is the data module, and as you can see, it has an EMS resource. It uses attribute to determine the name of the resource, and it has a generic registration method here. So /data is how you'll be able to access this this information. And here's where we are going to write our code. Before we write the code, we can make things easier by dropping a few components in. So I'm going to need to connect to a database first. So I'm going to use a FIDAC connection. Let me try this out because we get troubles with the database connections. This is working, so that's good. Now I also need to have a query. So let's drop in a FIDAC query. The FIDAC query should automatically get the connection. So now we can open the FIDAC query and write some very powerful and and complex SQL, like select star from employee. You can test it out right away. Looks good. Has a bunch of fields. What we're going to use on the client side is the full name, so full underscore name. That's something I'll have to remember to use on the client side. So that's the query. That's fine. Let's keep this closed and let's keep this disconnected just in case. And we need a couple of more things. If we, given we're going to do a FireDuck application that saves data to the JSON format, we need this JSON storage object. This basically drags in the proper unit where the information is required, and we, as for every FireDuck application that hooks to a database, we need the weight cursor as well. We don't need the specific Interbase physical connection, because that's automatically brought in by using the driver name, the proper driver. So that should be working. Okay, so these are the components we need. Now we can move to the code. So basically what we need to do, well, first we need to connect. That would be a nice thing to do. So let's say connected equals true. Second would be a good idea to run the query. Again, this is stateless, so every time this is executed, it connects and runs the query. It's not cached in any way. So I'm just going to open the query and not passing anything in it. Now we have our query and we have our connection. What we need to do is to fill in the response, this response field. So the response has a body, which is the actual content we're sending back. And the body has a few ways to set the value, but what we're going to use is set stream, return a stream. Now, of course, to do that, we need a stream. So let me get back here and declare a variable, a stream of type tstream. And of course, we'll need an actual instance, and the actual instance needs to be any memory stream. So let's just do stream equals t memory stream dot create. So now we have the memory stream, and then the next step is saving to the stream. So what we can do is take our FireDuck query and call save to stream and pass in our stream. The second parameter is the format we want the stream to be in. There are a few options we can use for formats. We can use XML, you can use binary, you can use JSON. In this case, we're going to use JSON. It's not always the ideal solution because binary would be more compressed, but if we want to make something open based on REST, that's a good option. The last parameter, oh no, sorry, last parameter goes down there. So now we have the stream, now we can return the stream as a result. And there are two further parameters here. One is, oops, is it actually correct? Yeah, is the content type. So what is the content we are returning? And this is JSON, and JSON is generally part of the application JSON standard format. And the last thing is if we own the value, if we own the stream. So if we pass the stream as owned by the response, once the response is returned, it will free the stream automatically. So otherwise, if we free the stream right away, it's not, won't be available for the response. So that's kind of the standard mechanism. Let the response own the result stream. Okay, should be done. Let's try to save this first. I'm going to go in my XE7 folder and let's say, oops, client, oops, oh, come on, client, no, this is the server unit, wait, server unit 1, server project. Okay, and if we look at the project is actually the project of a package. And among the project options, there is the execution within a host application, which is the development version of the EMS server. And again, this is just a package we're building. So as we compile it, actually what happens that we have dependencies. So the compiler will ask us to drag in these things, which is fine and expected. And now we can rebuild it, and there's a warning. Oh, no, okay, no warning. That's fine. So let's try to run it. And of course, what we run is the development version of the EMS server, and that server will load the package. We can double check everything works by going in the browser. We get the version. This is an information that the EMS server returns us. But of course, now we can also ask for data. And here it goes. This is our query in a JSON format. And that's the information that's returned by the server. This logs the fact that there was a request and everything else. Good. So the next thing I have to do probably is just to rerun this, but as standalone, because what I need to do here is create a client. So let's do new and create a multi-device application. And I'm not going to focus much on the steps around the multi-device, this new Fire UI, multi-device designer. I'm just going to style it as a phone and use it in a very simple way. And the UI will be very simple, just a button and a list view. That's all I need for now. The button will be aligned to the top and the list view to the client. And that should be it. Okay, and let's call the button 1. That's good enough. So now what we have to do is to reach our EMS server. Now there are multiple ways to do this, and I know that she showed how you can actually use the REST components. That's fine, although it becomes a little tricky when you need to do the authentication part. But what I'm going to use here is the EMS provider. That's compatible with the BAS providers. It's part of the BAS, backend as a service client technology that we built in x86, and this one is specifically tied to EMS. So all I have to do here is refer to the local, to the server, local host, and the port, which is 8080. You can check the port as one of the parameters of the server. Well, and that should be it. We can actually test the connection to make sure we can actually respond. And as you can see, it returns version, which is the same thing I was testing in the browser earlier. So that's good. We have a connection to our provider. The other thing we need is an endpoint. An endpoint is a generic URL connection, a connection to a URL on the server. It hooks automatically to the provider. And what we need to do is refer to a specific resource that we've called data. So that's the name of the resource or the URL of the resource on the other side. We can hook it a response object, or we can just treat the resource. A response object will be created automatically. So it's not that another component is really needed. Now we need an FDMEM table, because that's where we want to store our information, even if just in memory in the client application. We need another of these JSON streamer, because we are doing the opposite operation. We are reading from JSON into the MEM table, but again, that's what FireDuck requires for this step. And then we'll also need to build user interface. So again, we have the list view, but we need to connect the list view with the data. A way to do this is to get to the fields editor, create a new field. It's going to be full_name, and we are just creating this at design time, so we can use visualize bindings to use the field automatically at design time. So now I'm going to open the live binding designer, and simply say that I want the table to be synced with the list view and the full name to be the text that's displayed. That should be it. Let's save this one guy first. Again, code XE7 and EMS live data, and this is the new client unit. And as I'm into it, okay, project, new client. Okay, so let's close this one down, and now we have to actually write the code that does basically the opposite of what we've done on the client side. So first of all, we have to execute the REST call, and that's means executing the backend endpoint. This makes sure that we have a response available. So now what we can do is actually we can refer to backendpoint.response dot content, and that's the data, that the string with the JSON that we have loaded from the server. And that the other step we need to do is to get our FDMEM table object and load that data. Now the way to load the data is, again, opposite from the other side, is load from stream. So we need a stream, no surprise. As we needed a stream on one side, we also need a stream on the other side. So let's call it a stream, and it's of type T stream. But then when we instantiate it, we can create any in-memory stream, but what is handy is actually I use a T-string stream, because then we can pass to the constructor directly the string with the content. So it just saves a little bit of code there. That should be it. And now we have the stream. I'm still not sure if this is required, but just in case, reset the position of the stream, because we are reading it back in the component, and then we can do the FDMEM table load from stream. We are reading our stream, and you guess what? It's another JSON structure that we are reading back into our application. There's one more thing we have to do this time. We don't have automatic management, so we need also to free our stream. And yeah, I should have used that final block or to make that safe. But I'm not going to do that. So the server is still running, so we can now run the save once more and run the client. And the client application, if all goes well, should be able to fetch the data and display it into the list view. Of course, the same code, but provided you plug in the right IP address or name of the server, would also work on a mobile application. So that's the idea. That's the scenario. Using a stream from on one side for creating the JSON format, and then reloading the stream in a mem table, and using the backend endpoint to access the resource. Now there is a better and nicer way, although it hides some of the details, which is why I wanted to go through this step and build everything from scratch. There is a nicer way, which is going through the FFireDAX schema adapter and using a specific conduit on the client side to make the call to the server. So the next application is actually more complex because it's a master detail structure, and as you'll see, there is actually much less code to use. This is the server. Again, it's another EMS module. In this case, we are connected to SQLite. It's not a connection to Interbase, just to show that you can use any database. There's nothing specific to Interbase. Interbase is required by EMS for the user management, but in terms of your data, you can use any server, although you have a free license of Interbase, so that could be an interesting option. Anyway, so this is working. There is a connection. Again, the driver, wait cursor, the JSON storage, same stuff. But now we have a schema adapter, and then we have two queries customers and orders that are tied with a master detail relationship. So the orders is really tied using master source to the customers table. Okay, so again, it's a master detail architecture with a little bit of complexity. Once it's set up, there is really very little code you have to write to return the data, which is up around the two queries. And then rather than returning the JSON for one or the other, you can just return the JSON from the schema adapter that already contains both with the master detail relationship defined inside this schema adapter, this stream. Okay, so similar code to what we've done, and the ability to stream in a single step the master and the detail. This resource is called test. So let's actually run this without debugging. And first, I need to stop the first one, the other one, because otherwise I have two servers that by default are on the same port. So that's not good. And let's open the browser and let's go to test this time. Okay, yeah, I mistyped it, so there's nothing there. And so this is our data structure with the master detail embedded in it. Now let's look at the client side of this application, which actually happens to be VCL application. It's not that EMS is specific to mobile in any way, although the name is kind of hinting in that direction. So here we have a data module. The data module has an architecture that mimics the server-side components with two mem tables and two table adapters. These two table adapters are the conduit to the schema adapter that keeps the two components together. Now, here there is a reference, which is the remote table name. So that's the name of the remote object that you can customize, and the same is here. And this is actually mem table, and with the components tied to them, the mem table that refers to the adapter and the adapter to the schema adapter. So there is a little bit of setup, but honestly, then there is no code in this module. So it might take a little to configure, but then it's extremely powerful. Now, what about the client side, the calling side? Again, we have the provider. Rather than using the endpoint, we have a specialized endpoint, which is called EMS client. Again, it refers to a resource. Again, it refers to a provider. It can have authorization and other features. And notice that it does refer to the schema adapter. So it knows which schema adapter to populate and to connect to. And so, oddly enough, the client side gets very simple, because all it has to do to fetch the data is to call get data. So the get data will end up executing the proper endpoint, which is described here, test, call remotely, and populate with the data the schema adapter, which implies populating the two memory tables that are connected in a master detail relationship with this user interface. So if now everything works, because I couldn't get this demo to work on the previous run, if this works, we can do get tables, and we get our master detail structure directly available in the client side. Yeah, that was good. Okay, so that's it. That's the idea. So again, using the FARDA client and the schema adapter implies writing even less code, although there is a little bit of extra complexity. That's why I wanted to build the first application step by step without this extra layer, but just going through the plain streaming mechanism. Notice that with another single line, you can actually take the delta, the change in the two mem tables, and send back the updates to the server. So it's equally powerful in terms of handling cached updates with the master detail structure and sending back those changes. But I think we are basically out of time. So as planned, plain JSON streaming or schema adapter and the specific FARDAC EMS client. These are the options that are available. So any question?
You can use any database, talk to Oracle, talk to SQL
Yeah,
Server.
absolutely. Any database will do the same approach, the same scenario, just use FireDuck. And the thing that we really, I want to underline is that really move to using FireDuck, like FireDuck mem tables all over the places. I know the client dataset is a very nice and fun component to play with. I've used it extensively over the years, but the power in the FD mem table is really superior to what the client dataset provides. And there are differences, like overall, the capabilities are great. And for example, this JSON mapping, which is built into in XC7, is actually very nice.
Then there's a question, if you have a mobile client and you're connected and you get some data, what happens when you stop the app, shut your phone off or whatever, and want to come back in?
Well, if you shut your phone off and close everything, you have to refetch the data. Now, the thing that this architecture and this technology is really focused on is to be completely stateless. So in the different scenario, which is you're getting the data, you're moving around with your phone, you lose the connection, your data remains in the app, you can store it locally by streaming the FireDuck or by saving to the Interbase local client. And then you can work on this data, and then you can connect and do even an update delayed over time to the server, because the connection is not capped. It's really completely stateful. You do a connection, you get the data, you disconnect. So the single execute operation you do on the backend component, when it's done, it's done. You don't keep a connection open. So this is really something, and again, in general, using REST technology, that really scales very well to mobile applications where the connection is there, but might not always be there. You might move from the Wi-Fi to a public hotspot and change your IP address over time. So you don't, if you keep the connection, or if you try to keep the connection open to a remote database, even under a VPN, you are in for a lot of trouble.
So if you have the data sitting in the FD mem table, let's say for your master detail or even your simple query, what should you do to save that data locally so that it's cached on your device?
Yeah, you can use the same technique, streaming technique, to say FD mem table save to file. For example, if you receive an event that the application is being shut down, you can save locally, so you don't have to fetch the entire data again when the application restarts. That's certainly a possible scenario. Now, the other thing that you might need a little bit work on is what if there is new data available. So right now, all you have to do is to make sure you have another query, another endpoint that lets you give me the last few records in the last 24 hours, so I don't have to refetch the entire table, but just get the new stuff. And that's a direction where we are investing, both in terms of EMS and FireDuck and Interbase, to actually make things much smoother in the future.
Bjorn is asking, what if the data contains blob data and a lot of records? What should you do?
Well, you should not send the entire table right away. You should certainly do return it in chunks, and you can do that both. You can reduce the table size both horizontally and vertically. You can only return a few fields, not the blobs, and then that's why there are two methods that by default are exposed by EMS, which is two get method, which is get and get item. Get is for getting the entire resource. Get item is to get an individual element. So for example, on the get, you might just want to return the ID. Let's suppose we go to employee, the ID and the employee name. All of the details, including the picture, which can be a big blob, you want to return when you do a get item. And the get item, you pass as parameter the ID, and so you have a second query, which is just get me all of the entire record, including the blob fields, for one single record, and then you return that back. So that's one way. The other way is to cut horizontally, to say, give me only the first 100 records, or only those that start with A, B, or C, or a geographical or a logical subset of the table. Of course, you don't fetch million records of a table on a mobile phone. That's kind of pointless.
So select star from.
Oh yeah, select star is not is great for these short demos.
Where it's a billion rows, right?
Yeah, but again, so both cut the number of, just return only a few selected fields for the generic get, and then just get item, but also filter out the records that are relevant to that individual user or customer. The most obvious would be you have a sales agent, only the customer in his area or the customer he sells to are returned.
And JT answered Lucio's, he had questions about the cost and packaging and deployment of EMS server and clients. We want to just cover that a little bit. JT answered it also with the data in the answer.
Yeah, the idea that this, as implied by the question, this is not a free to deploy technology. We charge for a runtime fee. That includes the Interbase server, the Interbase to go on the device, and the EMS solution. The rationale is that this really, again, makes it extremely easy to build an enterprise application with the analytics, with a lot of features built into them, with a very limited effort on the developer. We currently offer a minimum of 100 users count, and then the price scales up and gets significantly. You get a very significant discount if you really go into the thousands. But if you have like a specific scenario or a specific case that might not fall into our current licensing, we're actually very open to adjust the licensing model to specific cases. Like, for example, even having a lower starting point is something we're currently evaluating. So if you have a specific scenario, specific requirement, just send us email, and we're very open to consider it. Not if your request is, oh, but I want it free, sorry, no, that's not an option.
And again, one of the key things Marco mentioned is Interbase to go that you can put on the client side, so you can store encrypted data in an Interbase database on your mobile client, for example, at the database or at the column level.
Yeah.
To secure your data if someone gets your phone.
Yeah, absolutely. There is not just that you can, have data that is relevant that gets lost, but there is a liability on having data on the clear on devices. If there is any sensitive data in many countries, you can get fines, and that's been proved, and we have we've seen it with witnesses in several scenarios. So you really, there are, in many cases, the data really must be encrypted on a device. It's not just an option or a nice thing to do. And so if you consider the cost of that solution alone is roughly half of the cost of an EMS client license. So it's, again, you're buying a package that has a number of things in it. And of course, we're going to expand and extend EMS in future releases to offer even more ready-to-use features in the box.
Mylan's asking, are there any performance comparisons of EMS versus DataSnap, assuming that DataSnap uses stateless, just like EMS?
If you can tweak DataSnap a little better these days, for example, using a pure REST connection. There is a way to configure DataSnap with no sessions at all, although we don't really, we probably need to do a better job explaining it. But this is different because it's really built straight on, the only common technology is WebBroker between the two. DataSnap has a rather rich architecture because of the multi-phased approaches. You can still use TCP/IP and even COM, so it's a technology that has a lot of power and capability in many different scenarios, but that goes to the expense of being a clean, fast, straightforward solution in the REST case. So even if you're doing a DataSnap REST, you do have a little bit of overall DataSnap overhead. And honestly, there's very little way around it unless you want to lose completely all of the DataSnap compatibility from the past. So this is really a web broker-based solution. We are sure this is quite effective and powerful. However, notice that the development server that we are distributing is based on the HTTP server, and it's on purpose. It's a free development license, so it's not expected to be specifically performance. When you deploy EMS, and that's something we are going to ship soon. It's not actually available today, but when you deploy EMS, you'll get an ISAPI DLL, which has significantly faster performance. And also, given it's completely stateless and the only data about users and user information is in the database, it's actually quite straightforward to deploy it, for example, on 2 load balance servers with a single Interbase server and the backend that provides the user information. So this, again, it's completely stateless. It allows load balancing scenarios and more sophisticated scenarios. Now, you can also use data snap with load balancing, but it's a bit more tricky to set up.
There was a question here from David. Is EMS an Embarcadero term, or is it used elsewhere? And I already said it stood for Enterprise Mobility Services.
No, EMS is an Embarcadero term. In terms of category, if we want to put it into a category, it's a MEAP, Middle Tier Enterprise Application Platform, MEAP. This is a very vague collection of different technologies that fall into that space. So the space is not a generic middle tier, but it's enterprise specific. The data access is a big focus, and also somehow the easy to deploy, ready to use scenario is part of that picture. But I mean, the big difference, if you compare this to like Parse and Kimby that we support on the client side, these are BOS components, backend as a service. They're not meant to be enterprise integration. They're not meant to access Oracle or Interbase or your enterprise databases, and also they can only be hosted on a cloud system, while with EMS you can host it in-house within your firewall in a protected way. So it's again, the category is what is called MEAP, and EMS is a specific product by Embarcadero within that category.
And then the other part of EMS, there's a whole bunch of support for user support, grouping of user support, analytics, and so on, right?
Yeah, there are a lot of things in the box. I mean, it's kind of easy to get to them if we want to, because without doing anything, what this application can open the console and log in. Now we can see the users. There is one predefined. We can look at the analytics. I don't know, for example, the API calls, and we can see that there were like a few API calls today, and that's they might have been around. So yeah, I did calls with the previous session. I did calls now, and you can do monthly. Of course, there is only one. Well, that's the wrong day. Oh no, it's another time I did test though. So these are all the calls I did today to this server. So again, it's a lot of information, and also you can trim it down to API calls, so call point. So how many times I've called get version compared to data compared to test and other operations. So yeah, I mean that's out of the box without doing anything. You have this wealth of information that again is really focused on enterprise scenarios where tracking the users is a significant feature for an application.
And then David asked, does it only work with FireDAC, or can you use other backend databases?
You can use any database on the back end. If you want to use a different conduit, that's fine. I mean, if you go back to the first demo, the only features I was using on FireDAC was the JSON streaming back and forth JSON. So you can use whatever you want. It might be more difficult, not just to create the JSON, but maybe to like consume it then on the client side. But again, it's just code. So the architecture per se is just you provide an endpoint, you provide a REST call, you return some data that might not even be JSON, could even be binary or some other formats, or XML if you want to, and then you consume and use that data on the client side. So per se, it's not specifically tied to FireDAC, although some of the components like the Schema Adapter and the FireDAC EMS client, those are clearly tied to the architecture.
And again, EMS also uses Interbase internally for user storage, for
storing the data that's used for the analytics. And again, we provide that as free. So if you decide to use Interbase, once you've paid for EMS, because EMS is not free, once you've paid for EMS, you can use the Interbase server. But if a company uses Oracle, uses IBM DB2, uses any other database that FireDAC supports, or again, you can get to with any other Delphi component, that's equally fine.
And let's see, Eric was asking, he said, did I miss the setup of the schema adapter? How does it know what data it's getting?
Oh, there are components that push data to the schema adapter. So you have a bunch of components that refer to the schema adapter. So it's kind of an inverse relationship. You have components that refer to the schema adapter, and the schema adapter knows which components are hooked to itself, and then can leverage that knowledge.
And then David's asking, is EMS included with Delphi Professional?
No, EMS is included with the client-server pack because it kind of really relies on having either FireDuck or another client-server conduit. I mean, using EMS without data access would not really be like the common scenario. So if you have Delphi Pro, you can buy the client-server pack, the FireDuck edition, and you'll have the full EMS. Unlike DataSnap that requires enterprise.
And Kyle was asking, is EMS limited to a single server and a single client application?
No, EMS is quite flexible in that respect. So what you do when you do the real deployment is you deploy an ISAPI DLL. We'll support Apache in the future, but for now it's only ISAPI DLL, either 32 or 64-bit. So, for example, what you can do is, although you need a single Interbase server with the users, you can deploy it on 2 different machines and do load balancing among those machines. It's completely stateless, so there's no state, even session information kept on the EMS server itself. The only information is the user information that's kept in the database. So it scales. Now, when you buy, suppose you buy the minimum stock, which is 100 user license, if you create like 3 different mobile applications that have 100 users each, that's fine. I mean, a user can have multiple applications with a single EMS. If you have 3 different applications with 3 different sets of users and you have like 30 on each application, you can still buy a 100 user license and split those licenses among 3 different users. You'll even be able to have different ISAPI DLLs for each of these user groups and each of these client-side applications. So we try to make it extremely flexible in terms of the deployment. And the license is per user. So if you, within your enterprise you're building 20 different mobile applications with this technology, it's per user. So the 20 user can use the 100 user can use the 20 apps, and you need 100 licenses.
And is this, I mean, the first example you just built from scratch, right? The second one, is that shipped with the product, or
yeah, the first is built from scratch. I'll post the code or blog about it. The second is part of the product, so the database and the code ships. It's actually, I grabbed it from there because I had another version that was wrong. That was my mistake this morning. This is under the Rust Studio demos. Okay, I have them on another folder, but the Rust Studio XE7 demos, Object Pascal database, EMS, FireDuck resource. That's the folder for the demo.
Okay, let's see. So Alpha's asking, what about Linux? Linux server for DataSnap, Linux server for EMS, Linux server for REST servers, Linux server for Indy servers?
Yeah, we think it's a great idea to support Linux. So we're trying to make sure that in the future the product will be able to let you deploy DataSnap and EMS and other servers to Linux boxes. That's something that's in the roadmap, and we are actively researching. No date yet, but it's something we are really working on.
Okay, Marco and everyone, the question log is empty, so thank you all very much. This was a little bit longer than a normal skill sprint, but it's EMS and it's new, and this involves database stuff. So again, thank you everyone. Thank you, Marco.
Thanks a lot.